Good day everyone, my name is Rainah to Escat. Today I'll be teaching you about compound interest and annuities. So the first question prompts me, but before that, let's have a quick recap about compound interest. Compound interest is interest earned on an interest that leads to exponential growth. And here is a formula that we'll use, where A is equal to P when close 1 plus R over N raised to NT, where A, this is the present value, P is the principal amount or the present value, R is the rate, and N is the number of times the interest is compounded yearly, and T, that's the time in years. So now we're ready for the first question. Rainah invested 15,000 at 8% compounded annually for 15 years, while Raul invested 20,000 at 8% compounded annually for 15 years. How much money will Raul have in his account compared to Rainah after 15 years? Rainah invested 15,000, that's our P. 15,000 at 8%. So 8%, that's the rate. R is equal to 8%, or in decimals, that's 0.08. The letter N, that's 1, because annually it's per year, you have 1 year, so you write 1. And T is the time in years, says here, for 15 years. 15. So, first step, we plug in the values. So, A is equal to P, which is 15,000, times 1 plus R, which is 0.08, 0.08 over N, which is 1, raised to NT, and times T, 1 times 15 is 15. Yes. And that's all you need to do when you get your scientific calculators. Or you press 15,000. 15,000, open and close. 1 plus 0.08, you could divide by 1, then you raise it to 15. So our answer is 47,582.53671. See, that's only for Rainah, that's not so for Raul's. Raul invests 20,000 for Raul. This is Rainah. This is for Raul. So Raul invested 20,000. 1, 2, 3, 2. And R at same rate? Yeah, 8%. 0.08. And it's equal to 1. Compounded annually says there. And the time is still 15 years. So we use the same formula. So A is equal to P, which is 20,000, times 1 plus R, which is 0.08 over N, which is 1 raised to 15. Again, using a scientific calculator, let's first enter this part, the one inside the parentheses, then the exponent. So, open and close, 1 plus 0.08. Divide by 1. Then make sure you raise that to 50. Then you get a value, which is 3.172169114. And you click multiply by 20,000. And the answer is 60,443.38228. So that is the answer. Raul will have 63,443.38228, and Rainah will have 47,582.5367 after 15 years. Now to the next question. Next we have problem 2. Rainah invests 10,000. So this is number 2. Rainah will put Rainah. So that's P. P is equal to 10,000 at 10% rate. Compounded quarterly, so that rate is equal to 10% or 0.10 Compounded quarterly, in a year we have 4 quarters, so n is equal to 4. Next, while Rian, we have a second person here, Rian, invests the same amount, so 10,000, but at 13%, so rate is equal to 13% or 0.13 compounded quarterly as well. And is equal to 4 compounded quarterly for 30 years. So time equal to 30 time years is equal to 30. So how much money will Rian have in her account compared to Rainah after 30 years? So using the same formula, we plug in the values. A is equal to P, which is 10,000. 1 plus R, 0.10 over N, which is 4. Open and close, NP. N times T, so 4 times 30, that's 120. So now you get your scientific calculators. Yeah. So let's first enter this. Safe. So open and close. 1 plus 0.10 divide by 4, then you raise that to 120, then you press equals, then you multiply that by 10,000. 1, 2, 3. Now our answer here for Rainah is 193,581.4983. Now let's solve for Rian. Plugging in the values, we have 10,000. 1 plus R, that's 0.13 over N, which is 4 times NT, it's still 120 raised to 120. So now let's use our calculator. Open and close. First, 1 plus 0.13 divide by 4, raising that to 120. Equals, then multiply by 10,000. So Rian will have 464,309.147. Okay, so how much money will Rian have in her account compared to in after 30 years? So Rian will have for this 464,309.147 compared to Rainah, which she only has 193,581.4983 after 30 years. Did you get that, class? Now to the next question. Now for our third question. Rainah invests 5,000. So Rainah, P is equal to 5,000 at 4% compounded monthly. So the rate, that's 4% or 0.04 compounded monthly. In a year we have 12 months, so that's 12 and is equal to 12 for how many years? Oh, later. While Melody, a friend of Rainah's, so Melody invested the same amount. So same amount, 5,000. The same amount at 8%. So R is equal to 8% or 0.08 compounded semi-annually, that's half a year. So 2 6 months, so yeah, semi-annually, that's 2. How much money will Rainah have compared to Melody after 10 years? The time is equal to 10. Same here. That's 10. So let's solve. So A is equal to 5,000 multiplied by 1 plus R, which is 0.04 divided by N, which is 12. Raised to NT, 12 times 10, that's 120. So I'll show you why it's 120, because 12, then it's 0, 0, 2 times 1 is 2, 1 times 1 is 1. See, 120, so raised to 120. Let's solve it later. Let's plug in first Melody's value. So P have 5,000 as well. For melody, multiply by 1 plus r over n, so 0.08 over 2. Raised to nt, that's 20. N times t, 2 times n is 20, so raised to 20. So now let's get our calculators. So first, we start here with the parentheses. So open and close, 1 plus 0.04 divided by 12, raise that to 120. You'll get 1.4908, then multiply that by 5,000. The answer is 7,454.1634112. Next, for melodies, again, is for plug in the one inside the parentheses. So 1 plus 0.08 divided by 2 raised to 20. That will be equal to 2.19112. Then multiply by 5,000. You'll get 10,955.61572.
How much money will Rainah have compared to Melody after 10 years?
Rainah will have 7,454.16341. Well, compared to Melody, which is 10,955.61572 after 10 years. Now we're down to our last two problems. Okay, the last two problems will be about annuities. Let's review about annuities. Annuities in Tagalog is hulugan. This is the series of payments made at regular intervals. There are different types of annuities and we will focus about ordinary annuities. Ordinary annuities are payments made at the end of each period. Example, car loans. This includes two formulas, one for the present value and one for the future value. Problem number 4. Mr. Escat deposits 25,000 pesos at the end of every quarter for 15 years. If the amount will be compounded by 12% quarterly, how much will he receive after 15 years? It says here, at the end of each quarter and how much will he receive after 15 years. So it talks about the future value and we will be using this formula. FV, that's for future value, is equal to A times 1 plus I raised to N minus 1 over letter I. A is the amount of each annuity payment. Okay, then I, that's the rate. Actually, that's the rate. And it's calculated by dividing letter R and M together. So I is equal to R over M. Well, and here is the total number of payments. Mr. Escat deposit 25,000. 25,000, that's our A. So number 4. So A is equal to 25,000. A, then R is equal to 12%, or this is 12%, or 0.12. Then T, the time in years, says here after 15 years, so we write 15. Then M, number of times, so quarterly, so we have 4. In a year we have 4 quarters, so we write 4. Then we will also have letter I. And here it's I. Let's calculate it by dividing R and M together. So our R, that's 0.12 divided by 4. 0.12 divided by 4, use your calculators class. So that will be 0.03. 0.03, yeah. We also have N in here. So N is calculated by multiplying M and T, where M is equal to 4 times 15. So 4 times 15, that's 16. FB is equal to A, which is 25,000, times 1 plus I. 1 plus I, which is 0.03, raised to n, which is 60, minus 1 over I, again I is 0.03. So now let's use our calculators. Let's first plug this in our calculator. So open and close. 1 plus 0.03 raised to 60 minus 1. Then press enter or equal. Then you divide 0.03 and you get 163.0534. Then multiply that by 35,000. And the answer is 4,476,335.92. This is our answer. So how much will Mr. Escat receive after 15 years? So Mr. Escat will receive 4,076,335.92 pesos after 15 years. Now on to our last question. Okay, last question, problem 5. BDO offers 50,000 to be compounded annually. How much should rider deposit if he wants to receive 50,000 at the end of each year for 5 years? So it says how much should rider deposit? So it's in the present. So we will use the present value of ordinary annuity, where PV is equal to A times, A times 1 minus 1 plus I raised to negative n over I. So A, you have A is equal to 50,000. Then R, the rate, it's 15%, so that's 0.15. Letter M is equal to compounded annually, so 1. Annually is yearly, so 1. Then letter T, after 5 years time, 5. Then we have letter I equals R over M, so our R here is 0.15 divided by 1. Still 0.15. Then we have letter N, multiply MT, so 5 times 1, 5. So plugging in the values, so PV is equal to A, which is 50,000, multiplied by 1 minus 1 plus I, which is 0.15, close parenthesis, raised to negative, letter N, which is 5, over all this over I, which is 0.15 again. So your scientific calculators we need them. So this one first. 1 minus open and close. 1 plus 0.15 raised to negative 5. Oops, wait. Then you click equals to divide by 0.15. And now press again equals. Then multiply that by 50,000. And the answer is
167,607.7549.
This is our final answer. How much should rider deposit if 150,000 at the end of each year for 5 years? So rider should deposit
167,607.7549.
if he wants to receive 50,000 at the end of each year for 5 years. Okay, now we're done for our 5 problems that involves compound interest and annuities. Again, this is Rainah si Escat, and I hope you learned something from our today's lesson. Class dismissed. Bye!